Welcome to the Juniper Connected Security module. This module helps you identify high-level security challenges in today's networks. The module also describes basic network security design. Finally, the module helps you identify the key factors in Juniper network security focus. At the end of this module, you will be able to identify high-level security challenges in today's networks, describe basic network security design, identify key factors in Juniper network security focus. We live in a world where cybercrime is a common factor for any organization that is planning to implement and administer network services. Cybercrime is not new, but the stakes have never been higher. It doesn't take much research to understand that the cost of cybercrime is expensive. With the number of attacks increasing by 10% each year, and the cost of those attacks increasing substantially, network architects must not only consider, but prioritize security when planning, implementing, and operating the network. Security personnel trying to create the best in-class security implement the best security they can. From this, most organizations have many different security devices in their network, many of which do not communicate well with each other, if at all. This can cause security lapses as varying personnel are responsible for different devices and implement the security plan that is the best for their device. Adding to the struggle of securing an enterprise is the use of multi-cloud environments. All traffic to and from the cloud must be encrypted and monitored for security purposes. To monitor the traffic, it must be unencrypted, putting a burden on the security equipment to monitor and secure. Network security is a rapidly changing environment in which vendors must help create simplified security solutions to be able to overcome the onslaught of attacks now and in the future. One of the aspects of cybersecurity that gets neglected is detection. Understanding that most breaches are discovered by a third party long after the security compromise has happened should encourage a better detection plan. With an average of 211 days to detect and contain a breach, many organizations could be compromised and not know it. Business organizations are like living entities, and like most entities, they do not like change. Creating an environment of security is a daunting task. Security personnel must make it a priority to make sure that all levels of leadership are on board with a security plan. Once they understand the importance of security, it will be easier to create training programs and to purchase security equipment for the company. Maintaining enough trained staff members that understand the environment and the why of particular configurations can be a contributing challenge. As networks grow, so does the diversity of equipment and vendors that staff members must be trained on. As these changes appear, some staff member might choose to find environments where their skills are in need instead of learning new skills for new equipment. Understanding the cost of cybersecurity is a multifaceted problem for all businesses. Risk assessments must be made at many levels for differing categories of data. What would it cost if this data was taken? What skill set do we need to protect the data? What tools are needed to protect the data? This assessment must remain agile to be able to change as threats, data, personnel, and equipment changes. Any software that is harmful to your system can fit under the term malware. It is becoming more sophisticated in its ability to hide from scanners. Some of the ways it hides are encrypting data before transmitting, storing itself in memory so file scanners cannot find it, appear to send data to known websites, and download itself in multiple files and then compile on a server once it is through the scanners. Everyone wants to keep their bosses happy by helping them with almost anything they ask. But what if the request from your boss is really from a bad actor? Phishing is creating an email or SMS message that looks like it comes from a known source, but in reality, it is from a bad actor. This message will ask you to log into a fake website or send back private information that allows the bad actor access to systems or accounts in your control. Always be suspicious of email that asks you to log in to verify information. Email filters are never going to stop every phishing threat. threats are becoming more sophisticated as bad actors are becoming more organized and better financed. These threats are categorized under the title Advanced Persistent Threat, or APT. These attackers are increasingly associated with organized crime and nation-states. This provides the resources to find the best way to breach a network and stay undiscovered. Persistent is a reference to the determination of the hackers and their desire to keep control of your network. If the attack does not work, these new bad actors will continue again and again until an attack does succeed. Once they succeed in breaching the network, they work to stay undiscovered so that they may continue to exfiltrate data off of the network indefinitely. An analogy to APT is a shoplifter. The applications you are running need to be open to allow customers to use that resource. The best practice to find an APT is to watch for any deviation in action from normal users. Just as with a shoplifter, you allow them in the store and watch for the action that is an anomaly. As your network footprint increases, the challenges of maintaining security also increase. There are more devices to manage, more policies specialized for each situation. There are also new devices like the Internet of Things or IoT devices that have little built-in security and are easy to deploy. Many of these devices get deployed without approval or oversight of security personnel. How do you face all those challenges when your rate of deployment continues to increase? On top of the growing threat climate, customer networks have become a blend of standalone or best-in-class security products. This layered stack of specialized products might meet customer security goals, but can lead to a variety of issues, including operational complexity for administrators, isolated functions leading to gaps in defense, multiple vendors and interfaces leading to console fatigue, and separate, uncorrelated threat intelligence or telemetry leading to illicit behavior not being detected. The bottom line is that many vendors just don't work in harmony, failing to operate as a unified front against cybercriminals. Note that Juniper Networks emphasizes the importance of implementing standards-based solutions for improved interoperability with other vendors, but some vendors use proprietary protocols that are not always compatible with standards-based devices. Moreover, the fact that a network might include systems from a variety of devices means that the staff must be well trained in maintaining these systems. Not too long ago, a typical managed network had defined boundaries and edges. Network security was relatively simple, involving mainly a firewall between your network and the Internet, some basic user management credentials, permissions, and so on, and perhaps a mandated antivirus application. Everything was considered managed, and a BYOD mentality wasn't even an option. The problem with this approach is that once an attacker gains access to the network, they have free rein over everything inside. Defense in depth builds upon the perimeter security model by adding layers of security that must be breached to obtain access to information on the network. If one layer fails to stop an attack, other layers are encountered to thwart an attack. This multi-layered approach with intentional redundancies increases the security of a system as a whole and addresses many different attack vectors. Defense in depth is commonly referred to as the castle approach because it mirrors the layered defenses of a medieval castle. Before you can penetrate a castle, you are faced with the moat, ramparts, drawbridge, towers, battlements, and so on. Components of defense in depth include antivirus software, firewalls, anti-malware programs, password strength, intrusion detection, biometric verification, software patch management, and consistent configuration management. In addition to electronic countermeasures, physical protection of business sites along with comprehensive and ongoing personnel training enhances the security of vital data against compromise, theft, or destruction. Defense in depth has been very successful in the past at hindering and limiting attacks. Nevertheless, as attacks become more automated and focused, defense in depth is not able to work as well. The main problem is that the layers of defense do not communicate with each other. If an endpoint antivirus program finds a virus, it does not signal intrusion, detection and prevention, or IDP, or firewall defenses to stop further movement of the known threat. Zero Trust Security is a cybersecurity model that requires strict identity verification for every user and device trying to access resources on a private network, regardless of whether they are sitting within or outside of the network perimeter. It is rooted in the principle of never trust, always verify, and is designed to address lateral threat movement within the network by leveraging microsegmentation and granular perimeters enforcement based on user, data, and location. Lateral threat movement refers to attackers trying to move data through a network, trying to gain access to data and assets. Many attacks start at an endpoint or edge device and laterally move through the network to find access to the company's data. Zero Trust hopes to harden the internal network to repel attacks from hosts inside the perimeter. Today, information is often spread across cloud vendors, which makes it more difficult to have a single security control for an entire network. One of the reasons that cybercrime has become so prevalent in recent years is due to the ever-expanding threat surface. There are more ways than ever before for users and clients to connect to the network. Statistics indicate that most users access network resources with multiple devices, such as laptops, tablets, phones, and so forth. Furthermore, organizations are implementing virtualized systems to provide services to clients and customers. As organizations host more services and become the Internet of Everything for their users, administrators must be aware and combat the potential for cybercrime to occur on the network. Addressing these challenges early on in the design phase is imperative to a successful network architecture. To offer better network security, you must focus on the factors that optimize security in a network. Juniper has identified 6 principles to focus when implementing a secure network. Click each principle to learn more. If you are asked to name a security device, the firewall is likely the first thing you'd name. What does a firewall do? It permits only traffic that you specify. The stateful firewall has been around since 1994. It uses information in the first 4 layers in the IP packet header to verify if the packet belongs to an established session. Keeping track of these sessions is very CPU intensive. Juniper created ASICs to handle all the creation, maintenance, and teardown of these sessions, thus creating a faster and more stable firewall. In the old days, a firewall was intended to just be a firewall. In today's security environment, the firewall is expected to do much more than just permit traffic based on a set of static rules created at some point by the administrator. Other features that firewalls almost universally have are network address translation, or NAT, VPN, and routing. Juniper added additional features of reporting, analytics, and automation to their line of SRX devices. The next-generation firewall, or NGFW, builds on the traditional firewall features by moving detection up to Layer 7, the application layer of the OSI model. Application control and visibility enable the NGFW to block or accept traffic based upon the application or type of packet it is, and not just the port number that is being used for transport. Traditionally, TCP port 80 is open to accept web traffic to flow, but other application programmers started using TCP port 80 for transport because they knew their applications would work easier for the consumers. Application control and visibility would be able to stop all non-HTTP traffic going across port 80. Intrusion prevention is another addition that reads Layer 7 information to look for known patterns for a particular application or program. It is used for looking for known malware packets traversing the SRX in real time to mitigate infection before it gets to the host. Being able to allow or block applications based on who is accessing it is called user-based firewall. This option is an important feature moving forward. It provides access to only those individuals who need access, no matter where they are located on the network. Juniper has created an entire range of SRX series firewalls, from small office edge devices to high-end data center core firewall devices to virtual and container-based firewalls. There is an SRX series firewall for every need. These devices are derived from the Juniper Network's high-end service provider routers, so most industry-standard routing protocols are supported and run perfectly. The range of SRX series firewalls include the branch SRX series devices, the mid-range SRX series devices, and the high-end SRX series devices. Click each range to learn more. Unified Threat Management, or UTM, is a term used to describe the consolidation of several security features into one device to protect against multiple threat types. The advantage of UTM is a streamlined installation and management of multiple security capabilities. The displayed security features are provided as part of the UTM solution. Click each security feature to learn more. Application Firewall, or AppFW, refers to the ability to take the results from the App ID engine and leverage them to make an informed decision to permit, deny, or reject, or redirect the traffic. Traditionally, applications like HTTP, SMTP, and Domain Name System, or DNS, use well-known standard ports and are easily controlled by a stateful firewall. However, it is possible to run these applications on any port as long as the client and server are using the same protocol as the well-known ports. Evasive applications could remain undetected with a standard firewall that functions at Layer 3 or Layer 4 by transmitting other protocols over these well-known ports that are usually opened by a firewall. Application Firewall enforces protocol and policy control at Layer 7. It inspects the actual content of the payload and ensures that it conforms to the policy, rather than identifying the application based on Layer 3 and Layer 4 information. Additionally, With the growing popularity of web applications and the shift from traditional full client-based applications to the web, more and more traffic is being transmitted over HTTP. An application firewall identifies not only HTTP, but also any application running on top of it, letting you properly enforce policies. For example, an application firewall rule can block HTTP traffic from Facebook but allow web access to HTTP traffic from MS Outlook. The SRX series device already supports Unified Access Control or UAC integration with Network Access Control or NAC and a user firewall that can derive its authentication source from Windows Active Directory through the UAC MAG series Junos Pulse Gateway. Many customers want simple user firewall functionality without full NAC and do not want the additional cost or complexity of user role firewall, which has Active Directory dependencies such as Kerberos, Spinego on browsers, Active Directory DNS or certs, and UAC configuration. The integrated user firewall fulfills the requirement for simplicity. It retrieves user-to-IP address mappings from the Windows Active Directory for the firewall policy's usage as match criteria. This feature consists of the SRX series polling the event log of the Active Directory controller to determine by username and source IP address who has logged into the SRX series device. Then the username and group information are queried from the Lightweight Directory Access Protocol or LDAP service in the Active Directory controller. Once the SRX series has the IP address, username, and group relationship information, it generates authentication entries. With the authentication entries, the SRX series user firewall module enforces user-based and group-based policy control over traffic. Juniper Identity Management Service, or JIMS, is a standalone Windows service application that collects and maintains a large database of user, device, and group information from Active Directory domains, enabling SRX series service gateways, including the VSRX virtual firewall, to rapidly identify thousands of users in a large, distributed enterprise. JIMS is installed on any compatible Microsoft Windows server. SRX series service gateways can create, manage, and refine firewall rules that are based on user identity rather than IP address. Query JIMS, obtain the proper user identity information, and then enforce the appropriate security policy decisions to permit or deny access to protected corporate resources and the Internet. To keep up with APT in our modern world, Juniper devices running Junos OS support comprehensive automation facilities. Almost all aspects of the operation of your network can be managed programmatically or with scripts. The approaches to automating a device running Junos OS can be categorized as either on-box, off-box, or a combination of both. On-box scripts are installed on devices running Junos OS. These scripts are invoked either directly or as a result of certain conditions being met. This type of automation tends to be less complicated and can be a good place to start if you are not familiar with automation. In contrast, off-box automation is managing a device running Junos OS over a network from another system. The other system could be a network management system or NMS, or it could be your laptop. The advantages of this approach are the availability of modern languages and tools, such as the Python language, as well as the ability to manage multiple devices from a single system. Sometimes an automation solution involves an on-box component that acts as an agent for an off-box management system running elsewhere. A number of configuration management products follow this model, such as Puppet and Chef. The different applications available for the Junos Space platform are displayed. These applications implement workflows that allow you to simplify network operations, scale services, automate support, and open the network to new business opportunities. Note that these ServiceNow and Service Insight applications require a valid support contract to function. Click each Junos Space application to learn more. Security Director includes powerful network security features, such as Application Identification Control with application signatures, as well as UTM, Intrusion Prevention System or IPS, Security Intelligence Support, NAT Policy Management, and Virtual Private Networks or VPNs. Security Director also includes integrated logging and reporting capabilities. Security Director enables administrators to utilize extensive policy control capability. This capability includes managing network security policy horizontally across multiple SRX series devices, and also vertically to manage logical systems or LSys instances. Security Director improves network security policy consistency and compliance, even as networks scale. It also speeds and simplifies security administration and reduces management costs and errors with efficient network security policy and workflow tools. Click the Additional Information button to learn about device management in Security Director. Security Director simplifies firewall rule management by providing a policy-based way to manage your rule set, and it introduces two high-level abstractions in the form of an all-devices policy and a group-level policy. Using Security Director, you have the ability to create one policy that applies to all devices, a policy that can be applied to a group of devices, or a single policy that is applied to a single device. Policies can also be copied and compared. Having the ability to compare policies is useful, as you can easily see if two policies are redundant, conflict, or if one is not necessary. This helps to keep your rule set efficient. Rules can easily be reordered by simply selecting the rule, then choosing whether to move it up or down within the rule set hierarchy. Comments can be created per policy. This provides an easy way to search for particular policy characteristics based on a keyword search. The VPN management capabilities allow you to easily create VPN topologies from which you can quickly add devices and define additional settings required for those topologies. Security Director can simplify the management of IPS and application firewall policies. Signatures are conveniently categorized and color-coded for ease of understanding and management. You can create and manage custom signatures using the IPS Policies workspace. As with the workflow of other Security Director policies, configuring and managing UTM policies is a straightforward process. Managing UTM policies from Security Director enables you to control all aspects of UTM from a single location across all SRX deployments. Security Director supports integrated logging and reporting capabilities using Log Director. Log Director is a Juno Space application that enables the Space platform to query a specialized log collector node. Network devices push syslog messages to the log collector node. Log Director then queries the node using HTTP requests. Unlike other Juno Space applications, Log Director does not provide a new landing page. Instead, Log Director is integrated with the existing Security Director web interface. Monitored events include security policy, device logs, IPsec VPN tunnels, resource utilization, application firewall rules, UTM events, and IDP sessions. SkyATP is Juniper Network's cloud-based malware defense service that protects your organization from the most damaging, hard-to-detect attacks. Having this level of protection is crucial. Firewalls, antivirus, and other traditional security solutions simply are not designed to defeat unknown and hyper-evasive exploits used by criminals today. SkyATP brings together sandbox, machine learning, and threat intelligence to deliver truly advanced prevention of these breaches. The ATP service delivers deep inspection, scanning file contents for signs of malicious intent, and actionable reporting. Juniper's goal is to not just report on malware that comes across the perimeter, but to offer inline blocking when possible as well. There are three key attributes to the Juniper Network's ATP solution. JNCIA-ATP integration with the SRX that enables both detection and prevention of threats. Juniper leverages techniques that utilize deception to trick malware into identifying itself, and therefore raising confidence in alerts that are generated. Much like security intelligence, minimizing false positives is essential as Juniper incorporates this type of technology into an inline device like the SRX, and Juniper leverages the security intelligence solution to push actionable intelligence of compromised hosts to the SRX so that customers can implement quarantine policies when infected clients are detected on the network. Using a cloud-based UI allows users to administer JNCIA-ATP from anywhere with an internet connection. A perfect example of how JNCIA-ATP can protect your business is its ability to rapidly detect and stop hard-to-detect malware like ransomware. As mentioned previously, the growth of attacks, like ransomware, is explosive and can hit without warning. With JNCIA-ATP alongside your SRX series device, you can find and block an exploit like WannaCry in 90 seconds. This approach truly prevents the spread of the threat and keeps your business running smoothly. The addition of Policy Enforcer and Security Director to JNCIA-ATP is the beginning of Juniper Connected Security. Juniper Connected Security describes the entire network infrastructure being managed as a single enforcement domain, providing enforcement points across the network where policy can now be deployed dynamically and in unison to block threats at points across the network. Juno's Space Security Director, combined with Juniper's cloud-based security services JNCIA-ATP, provides the foundation for an open policy engine. Security Director works in concert with these services to push policies into the network. By providing real-time feedback between firewalls, Security Director provides the ability to deploy policy across network devices the instant that it is required. Taking information from Juniper's JNCIA-ATP cloud-based service, as well as from third-party JOIP feeds to block malicious activities as they enter or traverse the network, the SRX series devices can be updated with signature or policy information. Using Policy Enforcer, a policy is deployed dynamically at the access layer as it adapts the network to protect it against threats. File types that typically carry malware are copied and sent to the cloud. A sandbox environment within JNCIA-ATP using static or dynamic inspection techniques manipulates the files to trick them in revealing their malicious behavior. When malicious files are found, they are blocked at SRX enforcement points automatically. If host devices are already exposed to the malicious file, Policy Enforcer will update Security Director's policy to create a firewall filter for the infected host, moving it to a quarantined VLAN or blocking all traffic to and from the host. The Juniper Advanced Threat Prevention or JATP platform is the latest in whole network security detection and enforcement. JATP detects malware, understands behavior, and mitigates threats with just one touch. It uses security data from multiple sources in your network, no matter the vendor, and works with any firewall or security information and event management or SIEM device to deliver fast, flexible, and automated responses to malicious activity. Its unique architecture eliminates the need for time-consuming, one-off customizations. You can easily create custom data collectors right in the JATP interface. Once defined, data seamlessly flows into the JATP threat behavior timeline, empowering security teams to quickly see what happened and when, all in a single comprehensive view. The ATP appliance helps customers identify and defend against new zero-day and targeted attacks, identify existing compromised systems, mitigate risks by updating existing security controls to defend against identified threats, reduce the time and cost to resolve advanced threats, and reduce exposure to advanced threats. It has flexible deployment options with physical and virtual form factors. JATP provides fast, flexible, and automated defense against malicious activity, working alongside any firewall or SIEM device, using an easy-to-use interface to collect and correlate threat intelligence from any security source. It enables effective mitigation of lateral propagation and insight into threat behavior at every step of the life cycle to pinpoint high-priority threats and reduce false positives. JATP has comprehensive third-party API support enabling compatibility with most network devices, such as Active Directory, endpoint antivirus, firewalls, secure web gateways, IPS, and Office 365 and Gmail email services. 3 key functions of the Juniper ATP appliance are detection, analytics, and mitigation. Click each function to learn more. Juniper Secure Analytics, or JSA, is a market-leading SIEM system that consolidates large volumes of event data from thousands of devices, endpoints, and applications into actionable intelligence that solidifies your defenses and validates compliance. Security teams understand the vital need to prevent corporate breaches by responding effectively to cyber threats in real time. They're defending against constant change, as attacks continue to hit from every angle. APT perpetuated by cybercriminals silently breach business defenses, hunt for valuable data, and disappear before they are detected. Insiders also pose a threat with their direct access to company data that renders perimeter security ineffective. You need end-to-end threat management that easily reduces the millions of security events occurring every day into a manageable, actionable list of suspected offenses. The ability to detect and track malicious activity over extended time periods helps to uncover threats that are often otherwise missed. As IT infrastructure becomes more distributed and vulnerable to attack, SIEM technology becomes more essential for real-time alerting, analysis, and auditing. JSA ingests any data type from any data source to automatically identify the offense across all sources. Juniper's advanced security offerings are part of a unified cybersecurity platform, Juniper Connected Security. Juniper Connected Security brings together a comprehensive portfolio, centralizing and automating protection. The entire network is operated and managed as a single enforcement domain, where policy and enforcement are deployed dynamically and in unison. SRX devices, virtual or physical, provide the NGFW services. Security Director combined with SCI-ATP or JATP provides the highly effective and rapid defense against cybercrime. With real-time feedback between firewalls, Security Director deploys policy across network devices the instant that it is needed. Policies are created and deployed based on current threat conditions by policy enforcer. Suspected malware is sent to a sandbox environment in SCI-ATP or JATP, where it is analyzed and tricked into revealing its malicious intent. Policy enforcer responds to the new threats by telling network elements such as firewalls and switches to block the threat in real time. JSA provides a visualization into the entire secure network domain, allowing quick decisions with the data collected. You have reached the end of this module. In this module, you learned to identify high-level security challenges in today's networks, describe basic network security design, identify key factors in Juniper Network security focus,